All right, so welcome to our Wacky Wednesday where this hair will live on forever. Finishing up chapter 4 this morning. So we're looking at our ratios, we're looking at rates, we're looking at unit rates. Now we're going to mix it in with graphing, which we did in chapter 3. So when we look at this information, we're going to figure out how we can make our ratio or our rate charts and then be able to plot it on a coordinate grid. Remember, on plotting, we have 2 points we have to have in our ordered pair. Ordered pairs are parentheses with commas. Our first one is our X, which tells us to run forward if it's positive, backwards if it's negative. Our second one is our Y. It tells us to jump up if it's positive or jump down if it's negative. Our scenario that we have set up on this one here says a car travels at a rate of 50 miles per hour. Use equivalent ratios to graph the distance the car travels over time. So we have our ratio chart or our rate chart down here. We can see what our original ratio is, which they tell us is 50 miles per hour. So we know that that's 50 miles, has to have a label since we have a rate now, over 1 hour. So we know it's a unit rate because not only does it have labels, but it has a 1 as our denominator. And our unit rate will always be at our very beginning of our chart. So I know that as I go step by step by step, I'm just simply going to multiply it by our regular multiplication facts to get my next set of numbers. So my next set of numbers, I'd be multiplying by 2's. So then I would have 1 times 2 and 50 times 2. That's going to give me 100 over 2. My next step would be multiplying by 3's. So I'm going to multiply 50 and 100 by 3. I'm going to get 150, which they already give you, over 3. The next one they give us is 200. I know if I take 50 times 4, I get 200. So I would have 200 over 4. And then they tell me I'm going to use 5 for my next one. So multiplying by 5s, I have 5 times 1 is 5, but 5 times 50 is 250. My next step, though, is in the directions. It says then graph time on the x-axis and distance on the y-axis. And right below, they give us this chart here. We can see the x is going forward, and it says time. We can see the y going up, it says distance. So I just have to make sure that my X is my bottom number from this chart and my Y is my top number from this chart. When I'm plotting them then, I can see my X's go consecutive in numbers. So 1, 2, 3, 4, 5. And then my Y's are increasing by 50, starting at 50. So I just have to make sure I match them up correctly. So I have my 1 and 50, my 2 and 100, my 3 and 150, 4 and 200, 5 and 250. Then making sure that I plot everything correctly. Now on this, it's just in quadrant 1 because everything's going forward as a positive and everything's going up as a positive. So my X's are going to go forward, my Y's are going to go up, and I'm just going to plot them. So I went 1 and then I jump up to the 50. My next one is going to 2 and I'm going to jump up to 100. And then I go to the 3. And I jump up to 150. And then this one says to the 4, and I jump up to the 200. And then to the 5 and jump up to 250. Now, if I did that too quickly for you, then go ahead and pause, make sure that your book looks like this, and rewind it and play it again. These aren't designed to be really difficult or confusing. It's just putting a bunch of things that we've already talked about together as one. Going in a little bit of a reverse order for the next example then, because I'm going to have a plotted chart and I got to figure out what the information is that it's telling me. So it says, during a heavy rainstorm, the waters of the Blue River rose at a steady rate for 8 hours. The graph shows that the river increases in height over time. And we can see for 1 hour, 2 hours, and then we jump to 4 hours, and then we jump to 6 hours, and then we jump to 8 hours. We just have to figure out systematically how everything goes. And then it says to use that information. Use the graph to complete the table of equivalent ratios. How many inches did the river rise in 8 hours at the end of my information? So first I have to fill in the chart because that's what it tells me to do. Then I can answer the question. But most of you can answer that question just by looking at the chart because you understand what these graphic sources are telling me. Remember that my X is going forward for my time, because that's what it says. And then my Y is going up, and that's going to be my height, because that's what it says. My time has to be at the bottom then, because it's indicated here So this has to be my x-axis. When I look at my x-axis, I go on my points and I figure out which numbers I have. Then my y has to be the height because it indicates that this is going to be my height in increase in inches. I'm going to then have to match up that information according to where my x is. So I know I can see that I have 1 and 2 consecutive one after the other, but then I have to pause because I don't have a 3, but I do have a 4. So that would have to be my next one at the bottom of my ratio box. And then I have a 6, and then I have an 8. With that being the case, then I match up where my y's are. So on my y's, I went forward to the 1 and just up to 3. And then on my 2's, I went forward to the 2 and up to the 6. But on the 4, we had to skip. So we went to the 4 and then jumped up, and that gives me 12. 6 goes up to 18, and then the 8 goes up to 24. So as I'm looking at that, I can answer that question when it says, well, how much did it rise in 8 hours? Well, in 8 hours, it went up a total of 24 inches. All right? Going from this information then, so I just made that image smaller, answering these questions, thinking about what that's telling me. So then question 1 says, describe the pattern that you see on the graph in the table. So when I look at it, it looks like there's kind of a gap. But we could see that everything lines up evenly. And if I wanted to go to the 3, it would line up at the 9. If I wanted to go to the 5, it would line up to the 15. Everything does increase systematically at a steady rate. So for every hour, it increases 3 inches. So my unit rate on that would be 3 to 1. Explain how you know that the ratios in the table are equivalent. If I would break those down, every single one of them, and reduce them, they would all break down to 3 over 1, which we just said was our unit rate. So they are evenly spaced and reduced, they would come back to the original 3 over 1 or 3 to 1. And question 3 says, Matt earns $12 per hour. Explain how you could use equivalent ratios to draw a graph of his earnings over time. So it has nothing to do with this information here. They're just saying take it from what we just looked at and apply it to a different scenario. So how could I graph that? Well, to plot it on an axis, we would move every hour on the axis, so 1, 2, 3, 4, 5, so on and so forth, to the right. And then for every one of those, we would increase by 12 on the y, which is what we see here, increasing on the y at equal rates. It's what we saw in the first question, increasing on the y at equal rates as we went across. All right, you don't have that down, pause, finish up the answer, and then moving on. So this is what the homework is going to look like. So make sure you're focused and following along and taking your notes and filling out your book. It's a good reference then to go back to in case you have any questions on what we had done in class. All right, so question 1. Complete the table of equivalent ratios for the first 5 years. All right, so when I look at it, it says, a redwood tree grew at a rate of 4 feet per year. Use this information for 1 through 3. So if I have an increase of 3 per year, I know that, 4 per year, that my unit rate then is going to be 4 feet on my top over 1 year. And then I would just consistently increase from 1 to 2 to 3 to 4 to 5. So if I have 1 to 4, then I multiply that by my 2's, and it tells me that because I get my denominator of 2 already. So I have 4 times 2. Then I'm just going to multiply by 3. Now, don't go back to the 8 and the 2 and multiply by 3. Remember to go back to my original ratio or my unit rate. So I multiply by 3's here. So 3 times 4 and 3 times 1 gives me 12 thirds. Then I'm going to multiply by 4's. 4 times 4 is 16, and 4 times 1 is 4. And then I multiply by 5's. So 5 times 4 is 20, and 5 times 1 is going to give me my 5. So I have everything matched up. I can see that time is at the bottom of my chart. It's going to be my x. And I can see that height is on the vertical side of my chart. So that's going to be my y. Pairing those up then, as X at the bottom, Y on top, and I get my ordered pairs. I have 1 and 4, 2 and 8, 3 and 12, 4 and 16, 5 and 20. Those are my 5 ordered pairs that I can just then plot for question 3. So I have to number them. That's one of the things we have to do when we have a graph, and we're going to be plotting things on the graph because I have to know what my increments are. My increment for time is going by ones. So I just start with 1, 2, 3, 4, and 5. My increments for the height for the y-axis then is increasing by 4 because once again that's my unit rate. So on each line, as I'm going up, then I label 4, 8, 12, 16, 20. You could finish it out if you wanted to with 24, 28, 32, but you wouldn't have to. And then I just make sure I plot them in the exact point that they're supposed to be. I go forward 1, up 4. I go forward 2, up 8. I go forward 3, up 12. Forward 4, up 16. Forward 5, up 20. Notice once again, since it is an equivalent ratio set, it goes in a nice straight line. You could end up with information that doesn't go in a straight line if everything doesn't increase in an equal amount. On 4 through 8 then, so 4 says, the graph shows the rate, so it's already been done for us, of Lewis's car and how much gas it uses in miles per gallon. So I can see that I have a steady increment because it's a nice even growth. I could go from 1 gallon to 2 gallon to 3 gallon, and I can see that I'm growing by 30 every single time. So if that's the case, then I just need to do my chart by filling it in, or I could look at my 2 and see that it's going up to 60, look at my 3 and see it's going up to 90, my 4 is going up to 120, so on and so forth. Either way works to fill in my chart. I just did my multiplication facts. So I have 30 times 2 and 1 times 2. So that gives me my 60 over 2. And then times 3s, 30 times 3 is 90, times 4s, 30 times 4 is 120, and then times 5, 30 times 5 is my 150. Everything would match up nice and evenly on my chart. It says find the car's unit rate then of gas for my usage. Every one of those, if I reduce them down to their lowest term, would always come back to this. Notice unit rates, once again, have a denominator of 1, and top and bottom have labels. We had a lot of people missing those on the chapter 4 lesson 6 assignment, I think it was. We forgot the labels on our unit rates. We have to have labels on rates and unit rates for top and bottom. How far can the car go on 5 gallons of gas? Well, 5 gallons tells me 150 miles. Estimate the amount of gas needed to travel 50 miles. Well, I don't need to estimate. I can actually calculate that pretty easily because I can take that if I have 30 over 100, that's not what I solved for. I apologize. So let's do that real quick. If I have 50 miles that I want to go, and I know, I apologize. And I have 50 miles over something missing, then that takes us back to chapter 4, lesson 5, I believe it was. So if I divide the loop, then I would multiply 1 and 50, and I get 50, and then I just divide by the 30 that's there because I want to multiply the loop and divide by what's left over. So if I take 50 divided by 30, how many gallons do I need to go the 50 miles? Well, that would divide out to be 1.66666666 on your calculators. I just round to the nearest tenth. So 1.6 would be 1.7 gallons. Now, number 8, it says, Ellen's car averages 35 miles per gallon of gas. If you used an equivalent ratios on a graph and graphed her car's gas usage, how would the graph differ from the graph of Lewis's car and gas usage? Well, if it has an equal increment of 35 every time, the angle is going to look the same. It's still going to go up the further I go out. The time difference would be the same. The gallons of gas would be the same. The only thing that would differ would be my y-axis. Instead of increasing in increments of 30, then the y-axis would grow by 35 each instead of the 30 that we already have. Right? If you don't have that filled in, Go ahead and pause the video before you move on to the next slide, because the next slide tells us what our homework is. That's all there is to this lesson. Shouldn't be difficult. We should be able to watch the video, do our homework, and even check it in class to make sure that we get a good grade. This is our final grade for our midterms that are coming out this week. After this, the next 2 days we're going to spend doing chapter 4 test and making sure that we understand what it is that we're working on. So I'll be working with some people at the very beginning of class, reviewing a couple things that they didn't quite get on their assignments and things like that. So then when I get done with them and they're working, then if you have any questions, come back to me and ask.